All right, so once you get Desmos pulled up, clamshell your Chromebook. So once you get Desmos pulled up, clamshell your Chromebook. You don't need it just yet. All right, so today we are actually getting into quadratic functions. Now, we talked about this yesterday a little bit. What degree does a quadratic function have? So what's the degree of a quadratic function? 2. All right, so that means what? So what does degree mean? The highest exponent. So that means the highest exponent of a quadratic function is 2. So in other words, we're going to have an x squared in there somewhere and nothing higher. All right. So we've talked about, in Math 1, you talked about linear and exponential functions specifically. You did a little dabbling in quadratic, but those two are really the main meat of Math 1. All right. Now, they're pretty easy because they're always either increasing or decreasing the entire time. All right, so they're either going to be increasing or they're either going to be decreasing. There's no overlap. But with quadratics, that's not true because who remembers what a graph of a quadratic function looks like? So if I graphed a quadratic function, what would it look like? Just a general shape. It looks like a U, all right? It looks like either a U or an upside down U, depending on the way the function's set up. All right, so a quadratic function is a type of polynomial function, and this is the general definition below. So any function that can be placed in the form y equals ax squared plus bx plus c, where a cannot equal 0, but b and c can be 0. What does that mean? The a cannot be 0 because it would cancel out the x squared. All right. So in order for it to be a quadratic function, it has to contain an x squared in some shape or form. It can be, some examples, it could be x squared plus 3x plus 1. It could be negative 2x squared minus 3x. It could be 4x squared minus 1. All right. Or it could just be 5x squared. Any of these are considered quadratic functions. Notice how some of them can be trinomial, some of them can be binomial, some of them can be monomials. The common factor here is that they all contain those x squareds. All right. So they can have constants, they can have the x variable without a square attached to it, so an x with an exponent of 1, but they're not required to have those two things. What they are required for it to be quadratic is that x squared. All right. And that's exactly what answers our first question. So why is it important the leading coefficient to be non-zero? Because for a function to be quadratic, it has to contain x squared. All right. All right. Now, for letter B, out of those 4 functions, which ones are quadratic? Someone name me one. Owen.
Y equals x squared minus 3.
Y equals x squared minus 3. That one's quadratic. Someone else. Rajon. Square root of x? Not quite. We'll talk about that one in a second. Ephraim.
Y equals 2 minus x squared.
Right. So these are the only two. Why is this top right one not? It has the x squared, but why is it not a quadratic function? It has the x cubed. So remember, it's always based off of the highest exponent. Well, the highest exponent is a 3. So this function isn't quadratic, it's cubic. Now, what's wrong with the bottom left function? The square root of x. Why can we not have a square root of x? Remember, a quadratic function has to be a polynomial. All right, quadratics are polynomials. Well, is that even a polynomial? No, because remember, we talked about this yesterday or Friday. A polynomial function cannot have a square root with the x underneath that square root in it. All right, so because we have a square root of x with the x being under that radical, it's not even a polynomial. Thus, it can't be a quadratic function because it's not a polynomial to begin with. All right. So, given the quadratic function y equals 10 minus 3x squared plus 7x, we're going to rewrite it in standard form and state the value of the leading coefficient. So, what would be my first term? Here, let's go with Carolina. So, what's my first term if I'm putting it in standard form? Right, the negative 3x squared. So remember, standard form, it's going from highest to lowest exponent. All right. What's the next one? Ariana. Seven x. Good. So that means the last term is the 10. And wants us to state the value of the leading coefficient. What is the leading coefficient? Kaylee. All right, so remember, leading coefficient is the number connected to the variable with the largest exponent. So what's that number? -3. Good. So our leading coefficient is equal to -3 because that's the number connected to our largest exponent. All right. Now this next one, they gave us the function and they asked us to calculate what f of -2 is without using a calculator. All right. Now we've seen these before. All right. If you see f of -2, what does that mean you do? You plug -2 in for x. All right. So when we take f of -2, that means we plug in -2 for every x we see and then do order of operations. So I got f of -2 is equal to 2 times -2 squared minus 3 times -2 plus 1. Haven't done any simplifying yet. All I've done is plug it in. Now, based off of PEMDAS, what do I have to do first? Technically the parentheses, but remember in this case the parentheses are representing multiplication. So technically we got to do the exponent first, which is the -2 squared. All right, so be careful. Parentheses typically sometimes represent multiplication. So if there's no actual operation in the parentheses, but just a singular number, you don't do those first. All right, so what's -2 squared? 4. So this will be 2 times 4 minus 3 times -2 plus 1. All right, so we did exponents. What comes next in PEMDAS? Multiplication. So I got to do my 2 sets of multiplication. What's 2 times 4? 8. What's -3 times -2? +6. And then I bring down the plus 1. And then I just add those 3 numbers together. What's 8 plus 6? 14 plus 1? 15. So f of -2 is equal to 15. Yes. Yeah. Now, Remember, -2 was our input, so that makes 15 our output. Thank you. So let me ask you a question. If I was to graph that and then found where x was equal to -2, what would be its corresponding y value at that point? Or what point would it hit? We already found it. 15. So as a point on a graph, it would be -2, 15. Because remember, x values are the input. That's what we put in. And the y values are the output. So this would actually be, if we graphed this function, this would be a point on the graph. All right, so this right here is a point on the graph. Any questions on just some bare minimum basics? All right. Now, quadratics still behave in similar ways to other functions. So inputs go in, outputs come out. All right, so you put an x value in, you get a y value. But they start to behave differently from linear and exponential functions because outputs can repeat. So that's just a fancy way of saying the y values repeat. Because remember, the only thing that matters about it being a function is that the x values don't repeat. As long as the x values don't repeat, it's still considered a function. But that doesn't mean y values can't repeat. So with quadratic, it is infamous for y values repeating. All right. So, yes. Yeah. So we're going to consider the simplest of all quadratic functions, which is f of x is equal to x squared. This is also known as the parent function of a quadratic. All quadratic functions stem from this one. They're just all transformations of x squared. All right. So we're going to fill in this table without the use of a calculator because what's the only thing I'm going to have to do to get my y values if I'm giving the x values? Plug them in, which essentially all we're doing is what? We're not multiplying. We're squaring those numbers. That's all we're doing. All right. So what's -3 squared? Say it one more time. It's +9. Remember, negative times a negative is a positive. And a square is just multiplying something by itself. So we're doing -3 times -3, which is +9. What's -2 squared? +4. -1 squared? 1. 0 squared? 0. 1 squared? 2 squared? 3 squared? 9. Now, if you notice, the y values repeat. All right. What's the only y value that doesn't repeat? 0. The reason that this number is not going to repeat is because it's actually where our function turns. We'll learn what that's called in just a second. So we're going to take a minute and actually graph those points that we have. So I have -3, 9, 3, 6, 9, -2, 4, -1, 1, 0, 0. And if you notice, it's really easy to graph the other side because you should have the exact same y values. So they should line up with the y values on your left side. So that's the beauty about quadratics. Once you graph one side of the quadratic, the other side's easy because quadratics are symmetrical. Meaning every value, every y value on the quadratic function has a partner or a twin on the other side of the function. The only point on a quadratic is that does not have a y value that repeats is the vertex, which is called the turning point. So this right here is known as the vertex, which if you look, isn't this where that function changes direction? So like if I go from left to right, I just follow my pencil along the graph. I'm going down, 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 down until I hit the vertex. And then what do I start doing? Going up. All right. Now, it then asks what's the range of the quadratic function. So who remembers what range means? Kind of. Someone explain further? So what does range mean? Someone has not talked yet today. So there's domain and there's range. What does range mean? Does anyone know what domain means? Come on, guys. I know you know what it means. What does it mean? Take a shot in the dark. What do you think it means? Kind of. I'll give you a hint. It's an interval. It's the span of all what values? The y values. So the range is your span of all y values. So in other words, it's from your lowest y value to your highest. All right. So what is my lowest y value? So we're going up, down. So from the bottom to the top. So what's my lowest y value? 0. All right. So 0 is my lowest y value. And we use a bracket because it's defined there. Now, what y value does it go to? Not quite. Because remember, these arrows mean it's going to keep going on forever and ever. So where does it actually go to? It goes to infinity. Good. So we say it goes from 0 to infinity. Remember, infinity always has a bracket, not a bracket, a parenthesis next to it. Now, if we wanted to state this as an inequality, I would say the y value is what in relation to 0? So if it's going from 0 to infinity, what numbers between 0 and infinity are we talking about? Are we talking about numbers greater than 0 or less than 0? Greater. And since it's defined at 0, we actually have a point there. We put an equal to underneath it. So the range is y is greater than or equal to 0. You got to know how to do that, guys. It will come back to haunt you a lot. It only gets harder as you go through higher levels of math. All right, I can guarantee you will see that again in Math 3. There's a whole unit on functions alone. All right, now, so now we're going to do a little bit more of a harder function. So we're going to use our graphing calculators, whether it's Desmos or your TI, to generate a table. Now, don't open it up yet. I'm going to show you how to do it in your graphing calculator first. Okay? Because in my opinion, especially when you're trying to find points, the graphing calculator is actually a little bit easier when you just need a quick span of points. All right? So, everyone take out their TI. Now, on my screen, all right, my screen should look like your screen. Okay? So, the very first thing you're going to do is you're going to go to the very top left of your calculator and you're going to hit the y equals key. It's the top leftmost key on the calculator. When you do, you should see the screen. If there's something inputted in Y1, hit clear. Now, we're going to type in the function that they gave us. Y equals in the top left corner. Now we're going to input the function that they gave us. Now to input a variable in your calculator, do you guys see this green alpha key? You're going to click the key to the right of that. So you see where it says like xt and then some other stuff? Click that. It'll input an x. And then we just do how we'll do like square any number. We hit the caret key squared, hit the arrow key so it comes out the exponent. Then what was it? Minus 2x plus 8? Is that what it was? 2x minus 8. Okay. Then we hit minus 2, hit that x key again, and then minus 8. Has everyone inputted that function into your calculator? All right. Now, this isn't called, it's not called a graphing calculator just for laughs. If you hit the top rightmost key that says graph, it's right here. It'll actually, hold on. It'll actually graph your function. All right. Now, if it graphed it stupidly, hit this zoom key and hit 6, and it'll reset it. Now, I said we wanted a table. Well, it automatically generates a table for you as well. So what you're going to do is you're going to hit that blue second key and then hit that graph key again, so the top rightmost key. And it generates us a nice little table. Now, we can use our arrow keys to go through all the x values. All right. Now, why I like this over Desmos is because, remember, when you generate a table in Desmos, after a while, you have to start inputting x values. All right. The calculator always, in the TI calculator already gives you the x values. You just have to scroll through to get the ones that you want. All right. So it just makes it a little bit easier in that aspect. The TI table is easier when you just need a couple of points to graph. All right. So first off, I want you to look at the y values. We got to make sure we include the vertex, so the turning point. What appears to be the only y value that does not repeat on this table? So where does it look like the y values are starting to repeat again? After what number? -9. So if you look right here, -9, after -9, so it goes 0, -5, -8, -9, and then it starts repeating again, -8, -5, 0. All right, so that means that this point 1, -9 is going to be our vertex. All right, so what we're going to do is that we are going to, on our table, copy down this part of the table. So from x values of -2 to +4. Yes. Just say the graph button.
I mean the table.
Second, and then graph. Now, guys, if you notice, if you ever forget, the words are actually above. All right. So for table, you see it's how it says little blue table above the graph key. That means you hit the second button because the second button's blue. Graph key will generate the table. All right. So we're going to copy this table down here. So I'm just going to copy the table balance of x, y. I'm going to go from -2 to 4. So it went 0. What was the next number? So what was the value at x equals -1? -5, -8, -9, and then it repeats. So -8, -5, 0. Now, just to make sure that, let's say that you were at home and you didn't have your TI, all right, but you need to do this just to make sure you guys remember how to do this in Desmos. So very quickly, I'm going to graph this in Desmos. So we type in x squared minus 2x plus 5. All right. Now, the nice thing about Desmos is we don't always need to generate a table because sometimes they'll just flat out give us, I don't know why I put plus 5. It's definitely minus 8. All right. So the nice thing about Desmos is sometimes it already has some points graphed for us. All right. So for example, like the turning point, 1, -9, it automatically graphs it so we can click on it. Whenever you graph a quadratic, that vertex is always one thing that you need to graph. All right. Now it also graphs some things like your x and y intercepts. But if you need to generate a table, who remembers how to generate a table in Desmos? Say it one more time, Kaylee. So typically, if you want to generate a table to input something, so like input some values, you click this plus button and hit table. But we want to be generated from this function. Luke. You hit the gear key for settings. Right, then you click the little table picture. And it will actually create a table that corresponds to the function. Now, it automatically goes from -2 to 2. All right, that's what the x values all goes through. Now, where Desmos is nice is that you can input any x value you want. All right. So my recommendation is keep adding in x values until the y value is the one you start at, because remember, quadratics, they repeat. This would be 3, get -5 again, and then 4, we get 0. All right. So that's kind of the downfall about tables in Desmos, is that it automatically goes from -2 to 2 as x values, and sometimes those aren't necessarily even on the graph. All right. All right. So anyway, we got our table. So let's graph it. I always start by graphing my vertex and working my way around. So I'm going to start at 1, -9. Then I got 0, -8, as well as 2, -8. So it has its partner on both sides. Then I have -1, -5, and 3, -5. So it has its partner on the other side. Then -2, 0, and then 4, 0. So this is what our graph will look like. Now, based off of this graph, what is the range of the functions? We talked about this with the previous one. So what, remember, range is your y values. What is my lowest y value? Sure? -9 is. So -9 is my lowest y value, so we use a bracket. And where does it go to? What's the highest y value, technically? Infinity. These arrows mean it goes on forever. And we put a parenthesis. So if I wrote it as a inequality, so I don't care how you write out the range, you can write an interval notation, which looks like this, or you can write it using inequality. So y is what to -9? Is it going to be less than or greater than? Greater. And since it's equal to 9, it's defined there, we put an equal to underneath it. So I don't care which way you state it. You can state it either way. It's the exact same thing, just two different ways to state it. Now, it then asks, what is the domain interval where the function is increasing? So domain means what? X values. So we're looking at X values where the graph is increasing. So the way we figure this out is we go from left to right. I'm going to start by dragging my pencil at the leftmost point and ask myself, am I going down or up? So am I going down or up here? I'm going down. So this is actually my interval of decrease. Now, once I hit the turning point or the vertex, remember the vertex, the other name for it is turning point because it's literally where the graph turns. All right. So once I hit the turning point, instead of going down now, I'm going where? Up. So this is my interval of increase. So when we're asking for where the interval is increasing, first off, it's always going to be X values. So look from left to right. Now, if that's hard for you on the picture itself, here's a little trick. So go back into Desmos. So in Desmos, you can actually remove an axis. All right. So if you, do you guys see this little wrench key in the top right corner? Click it. Now, since we know that increasing intervals are only X values, and I don't want to get confused by the Y values, I want to take the Y axis out so I don't even see those numbers. All right, the way you do it, you go to where it says Y axis, you see how it's checked? Well, uncheck it. And if you look, the Y axis is completely gone. Doesn't even have numbers anymore. All right. So here's my question. We know we're increasing from the vertex, and then we go on to infinity. So what is the X value of which I start increasing? So look at Desmos. Where do I start increasing? We know that this is the turning point. So where does it actually start increasing? Nope. At 1. So it starts at X equals 1 because that's where we turn. All right. Because remember, there's a lot of minuscule points between this point and this point. All right. So we just say it starts here at 1. And then when does it stop increasing at that point? At infinity. So in other words, it never stops increasing from there. So the way we write this is 1, -9. We're going to start at 1. Now, technically, we are not increasing or decreasing at the vertex. So instead of using a bracket at 1, we use a parenthesis because it's not quite defined there, meaning we're not actually increasing at 1. It's like the only gray area. We're neither increasing or decreasing at the vertex. So we go from 1, then we go to infinity. Now, if we wrote that as an inequality, X values have to be what to 1? Greater than or less than 1? Greater. So at any X value greater than 1, our graph is increasing. That's what that means. Any questions? Yeah. Now, just for funsies, I know it said increasing, but what would we say if it was decreasing? Where does it start decreasing? What's the lowest X value at which it starts decreasing? Negative infinity. All right. Because it starts way up here where the arrows are. And even though it gets, higher and higher as we go, the X values still go on forever on either side. All right. So we start at negative infinity because we're talking X values, not Y values. All right. And then where do I stop decreasing? Not -9. Remember, what's the only thing we use? Not -1. We only use not y values, but x values. -9 is the y value. So I want the x value. So what's that x value connected to the -9? 1. So is it decreasing at x values less than or greater than 1? Less than. So that's going to be less than 1. So this is the interval of increase. That's the interval of decrease. And notice, if you combine them, you should have from negative infinity to positive infinity. All right, so our graph starts at negative infinity, goes to 1, then it flips and starts increasing from 1 to infinity. So it spans all the numbers. Now, we're then going to state the coordinates of the vertex, which is the turning point. We already know what that is. What's that point? 1, -9. So once again, that is our vertex. Now, axis of symmetry. All right, axis of symmetry of a parabola, which is what a quadratic graph is technically called, is an equation of a line, all right, that cuts the graph in half. So remember, a quadratic graph is always going to be symmetrical, meaning if I fold it over vertically, so if I fold it over a vertical line, like a piece of paper, it would line up perfectly on the other side. All right. So my axis of symmetry, where it perfectly cuts in half, because remember, if I look, the y values start repeating. What's the only y value that doesn't repeat? -9. All right. So that means my axis of symmetry has to be where the only y value that doesn't repeat. So right here. So this is my axis of symmetry. Now, since it is a line, it's not a number that we have to write. We have to write as an equation of a line. Does anyone remember what a vertical line equation looks like? Ephraim? Nope. Vertical line is the only equation that's not y equals. It's x equals. So the equation of the line is going to be x equals some number. Well, x equals 1. So your axis of symmetry always comes from the x value of your vertex. So your axis of symmetry is x equals 1. Now, the x-intercepts of the function. Now, these are also known as the function zeros. So we already graphed the x-intercepts in this case, but if we, for whatever reason, if we didn't, remember, you can always go to Desmos, and I'm going to put the y-axis back. You can always go to Desmos, and it will mark the x-intercepts for you automatically, so you can just click on them. So what are my two x-intercepts? Where are they at? Where are my two x-intercepts, guys? So on the x-axis, where are the 2 points? -2, 0, and 4, 0. Those are my x-intercepts. You can also call them the zeros. You may also see them as roots or solutions. Now, these are the points. So -2, 0, and 4, 0. Why do you think we can call x-intercepts zeros? What about the points of an x-intercept do you think makes it that lets us call it zeros? The y values. So, because if we input a -2 or a 4 into our original function, our output would be 0. So we can call it zeros because our output, so remember that's just fancy for y value, is 0. Any questions on that? Now, that's if we have a graph. Now, look at this table. All right. So, with the table, you can also get features from a quadratic function by looking at the table. Okay. So, what are the coordinates of the turning point? So remember, turning point is the vertex. So if I was looking at the table, think about when we looked at the table on your calculator. What kind of clued us in to where our vertex would be? Someone has not talked today. What the y? What part of the y? So it has something to do with the y's, but what? So your vertex would typically be the only y value that doesn't do what? Not change, repeat. All right. So your turning point contains the only y value that does not repeat. So if you look at this table, what is the only y value that doesn't repeat? 13. Now, the table extended a bit further. So if you look, technically -2 on this table doesn't repeat either. But remember, quadratic graphs are symmetrical. So since this one has 4, 4, we can assume that at -2, when x is -2, y would be -2 because they're symmetrical. All right. Another way you can look at it is that if you look on either side of the 13, the y values are increasing on this side, but they're decreasing on this side. So they're literally going up and down. So this would be my vertex. So what's the actual coordinate for the vertex? 213. Now this table is just a yes. Yes. Now this table is just a snapshot of the actual quadratic function it came from. So if we graphed not this quadratic function, what do you think the range would be? So look back at the previous one. Where did we grab our range from? What y value did we use? The y value of the what? The vertex, right? Well, don't we know what the vertex is? So can't we get the range? Yeah. So we know it's going to have 13 in some shape or form. Now, here's the question. On either side of the 13, are the y values getting smaller the further away they get from 13 or bigger the further away they get from 13? So in other words, what I'm asking is 13 the biggest number or the biggest y value or the smallest y value? So if you look at these y values, guys, is 13 the biggest or the smallest? It's the biggest. So that means that turning point, will it be a max or a min? It's a be a max. So our graph would look like this if we graphed it. So would 13 be my biggest y value or my smallest y value? Biggest. So that means since it's the biggest, it's going to be on this side. So that what would be on the left? What would be the smallest y value? Not infinity, but negative infinity. So if we rewrote this as an inequality, y would be what to 13? Greater than or less than? less than or equal to, because it is equal to 13. So sometimes you will be given a table. It's okay, just be careful. All right. It's all about the y values. More often than not, the y values are what clue you into a lot of things on a table. Any questions on that? All right, we're almost done. All right, just to recap. Features of the parabola. All right. First off, we got your vertex, which is known as your turning point. We then have your axis of symmetry, which is usually x is equal to some number. And remember, it comes from the x value of your vertex. So whatever the x value of your vertex is, that's your axis of symmetry. You just have to make sure you put x equals. So guys, if this was on a test, this is important. If I asked you what the axis of symmetry was on a test, let's say in this, so like for example, on this graph, it's 1. If you just put the number 1 and do not put the x equals, it's wrong. All right. Then you have the x-intercepts, which is just where it crosses the x-axis. And it's typically written as a point, some number, and 0. So that's what it is as a point. And remember, quadratics can have more than one x-intercept. Sometimes they have 1, sometimes they have 2, sometimes they have none. Y-intercept, there's only ever going to be one of them. And that's where it crosses the y-axis as a point that's 0 and some number. And then remember, some other things that I can ask you. I can ask you intervals of increase, decrease, positive, negative, domain, and range. All of these are intervals. So specifically, these are intervals. And the only one that uses a y value is range. So range is the only one that uses y values. Everything else, x values. All right. So now something else I may ask you is the direction of opening. All right. So if a parabola opens upwards, so it looks like this, that means we have a minimum value. Now, your a value of your quadratic always dictates that. So if it opens upwards, the a value of our quadratic has to be what? Positive or negative? Positive. So that's when a is positive. So if our graph opens downwards, that means we have a maximum y value. So it looks like that. So that means our a value would be what? Negative. All right, last thing, let's see if we can identify some features. So given this graph, all right, look at it for a second. What is my direction of opening? Let's go with Arielle. What's my direction of opening? Is it opening up or down? So look at the pictures. Which one does it look like? The one that's opening up or the one that's opening down? Down. So it's opening down. Now, before we find axis of symmetry, let's find vertex first. Because remember, if you find the vertex, it's easier to find the axis of symmetry. So where do you think the vertex is? So where do you think the graph turns? Let's go Kyrie. So at what point? -2 what? -2, 4. So that right there is the vertex. So from that, we can get the axis of symmetry. So what is the axis of symmetry? Rajan. X equals -2. Good. So it would be this line right here. That's my axis of symmetry at x equals -2. Now, since it's opening down, does that mean my vertex is going to be a max or min? Let's go Micah. So is the vertex the highest point or the lowest point on the graph? The highest. So it would be a maximum. Good. So the vertex is the highest point on my graph. It's the top of the mountain. So it's a max. All right. What is my y-intercept? So what point do I have a y-intercept? Caden, M. Close. Look carefully at it. Well, it's 0, but count. You got the wrong number. It's not 2. It's 0 is 3. So the y-intercept is right here at the point 0, 3. All right. X-intercepts. What is one x-intercept, Ephraim? I just want. So -5, 0. So right here. That's a 6, yeah. -6, 0. So that's an x-intercept. What's the other x-intercept? Luke. 2, 0. So that's the other x-intercept. Now, domain. So we're going from lowest to highest x value. So what is my lowest most x value? And remember, look at the ends of the graph. We do have arrows here. So what do you think my lowest most x value is, Dylan? So if I look from left to right and I have arrows here, what do you think my lowest x value would be? So we'll keep going on forever to the left because of the arrows? Yes or no? Yeah. So that means our lowest most x value, if it goes on to the left forever, that means the lowest x value has to be what? Has to be -infinity. So that's the first part. So what's my highest x value? Abby. Right. So from -infinity to +infinity. Does anyone remember another way we could state that? There's a phrase that we can use for that. Does anyone remember what it is? No, there's a phrase. So instead of saying from -infinity to +infinity, we can say the domain is blank, blank, blank. The first word's all. All blank, blank. All real numbers. All right, so we can also say it's all real numbers. We can also write it as the capital R with a line through it. So if you write any of these three things, I would take it. And lastly, range. So what is my lowest y value? Let's go Riley M. So what's the lowest y value? All right, so there's arrows down here, so it means it keeps going on forever. So what's technically the lowest y value if you look from bottom to top? Infinity, but since it's on the downward side, it has to be, there you go, negative infinity. So it goes from negative infinity, and then what's my highest y value? Yes, Owen. So it's my highest y value.
Is it 4?
Yep. It's always whatever the y value of the vertex is. And we use a bracket because it is defined there. So you got to be able to find all these key features. All right. Okay, any questions on this? All right, so your homework for tonight is a delta math. Now, it does cover 3.3 as well. You should be able to do everything but the last two sections. All right? You should be able to do everything but the last two sections. All right? So you guys got a solid 20 minutes. Go ahead and get started.
So I don't miss the bell.
Ask Ms. Davison to write your pass. Ms. Davison, can you write Ralph a pass to the media center? Just grab a sticky note.